Hello everyone. Today I'm presenting perfect competition. We'll look at the spectrum of markets and we'll look at visualizing costs alongside marginal revenue and marginal cost. Okay, first let's start with the spectrum of markets. On the spectrum, right, on one end we have perfect competition, on the other end we have monopoly, in the middle somewhere we have imperfect competition, under that we have monopolistic competition and oligopoly. My future videos may cover some of these, but for today let's look at some of the features under perfect competition. There are many buyers and sellers. No one can actually influence prices, and a standard good is sold. For example, white socks, white t-shirts, right? Standard generic goods. And then there are free entry and exit in perfect competition. The two most important ones that, well, in my opinion, the two most important ones that will help us understand a bit more what I'll be doing today is that no one can influence prices and that there are free entry and exit. Okay, now before we jump into more details, let's visualize costs alongside marginal revenue and marginal cost in perfect competition. Before I dive deeply into that, well, we'll first look at total revenue, variable cost, fixed cost, total cost. Now, I am working in the short run. In the short run, we have fixed costs. And so that's why fixed cost is in here. But let's review some of the formulas. Total revenue is calculated as P times Q star. And you'll see soon why I have Q star here. Variable cost is calculated as total cost minus fixed costs. Variable cost can also be calculated as Q star times ABC, average variable cost. How is that possible? Well, think about this. To get your average variable cost, you need to divide variable cost by Q star. And so if you multiply Q star by average variable cost, you have variable cost. In certain books, instead of Q star, they write TP, total product. It's the same thing. Total product is the same thing as Q star. Okay. All right. Now, to get fixed cost, we take our total cost and we subtract out variable cost. Fixed cost can also be written as Q star times AFC, average fixed cost. And again, I have here average fixed cost is written as fixed cost divided by Q star. So Q star times average fixed cost equals fixed cost. Other books, instead of Q star, will use TP, total product. Same thing. Now, total cost. Total cost is calculated as the sum of variable cost and fixed cost. Total cost can also be calculated as Q star times average total cost. How is that possible? Well, look just here. You see, average total cost is total cost divided by Q star. Multiply Q star by average total cost and you have total cost. Okay, so just a small review of some of these formulas. And so now we head over to visualizing cost. To be able to visualize costs, first I need to get the profit maximizing quantity in perfect competition. So, well, I said earlier on that one of the features of perfect competition is firms cannot influence prices. So we need to draw that. What does that mean when firms cannot influence prices? You'll see that shortly. But let's start in the entire market, right? Let's start in the market. So in the market, we have a downward sloping demand curve in blue and an upward sloping supply curve in red. Do you see where they intersect? At the point of intersection, let's call that point E, that is where quantity supplied equals quantity demanded. Some of my students say where demand equals supply. No, no, no. That is not where demand equals supply. When you say demand equals supply, you are forcing the red line to sit exactly on the blue line at every point. That's not good, right? Because one is sloping up, supply is sloping up, demand is sloping down. And so at E, we say quantity supplied equals quantity demanded. Great. So this price, equilibrium price, PE, it's going to be indicated to each firm in perfect competition or in the perfectly competitive market. And so, well, this is PE, but this is also marginal revenue. And it is each firm's demand curve. So in case you're wondering, why is this marginal revenue? I have a little bit of work down here to walk us through that. Let's say, well, we know that total revenue is equilibrium price times quantity. And let's say our equilibrium price is $8. And we have some quantities here. 1 crate of fruit, 2 crates, 3 crates, right? So this is for a firm. Now, total revenue is PE times Q1 for total revenue 1. And so that's my $8 times the 1 crate. And so the total here will be 8. And total revenue for 2 crates, that will be, well, 8 times 2. And that is 16. For 3 crates, total revenue will be 8 times 3. And that is 24. Very interesting. Now, we are interested in how marginal revenue is just this constant line, also equal to 8, if our price is 8. Now, marginal revenue, as you go from producing 1 to 2 crates, right? 1 to 2 crates, well, that will be the change in total revenue divided by the change in quantity or output or total products. Okay, so that will be total revenue 1 minus total revenue 2 divided by Q2 minus total revenue 2 minus total revenue 1 up here. Okay, then Q2 minus Q1. Okay, so that will be 16 minus $8 divided by 2 minus 1. The answer is 8. Okay, interesting. Well, marginal revenue, when you go from producing 2 crates to 3 crates, right? 2 crates to 3 crates. That will be the change in total revenue divided by the change in output. So total revenue 3 minus total revenue 2 divided by Q3 minus Q2. Okay, that is $24 minus 16 divided by 3 minus 2. Okay, 8. So I hope you believe me when I say that marginal revenue in perfect competition is price. Wonderful. So now that we have this, I'm going to change my color. And, well, I'm drawing here the marginal cost. In perfect competition, the intersection of the marginal cost and marginal revenue helps us obtain the profit maximizing quantity that this one firm in the perfectly competitive market should produce. That's pretty neat. Now, let's call that intersection point A. I said earlier on that we were going to visualize costs alongside marginal revenue and marginal costs. In fact, we will also visualize total revenue. And we have actually right here. Total revenue is this entire area shaded in blue. Total revenue goes from 0 to Q star to A to PE and back to 0. Total revenue is your sales. When each firm sells crates of fruits, that is what they get. This shaded area is what they are receiving. That is what P star or PE times Q star means. PE times Q star is taking the area of the shaded part of this graph. So the height will be PE and the base will be Q star. So this is why your total revenue is P times Q star or PE times Q star. And that area is illustrated right here, shaded in blue. Okay. Next, I will draw the average variable cost and the average total cost so that we can visualize the other costs. Okay, so let me make a small note here that total revenue is the area that goes from 0 to Q star to, 0 to Q star to A to PE and down to 0. To A to PE and back to 0. So that's that area shaded with the blue dots right here. Okay. So let me change my color real quick and draw for us. So this is my average variable cost and my average total cost. If you notice carefully how I'm drawing it, and you've probably had a class or two on production and cost, I'm drawing these cost curves, these average cost curves, so that the marginal cost is crossing the average variable cost at the minimum point of the average variable cost, and the same is happening for the average total cost. The marginal cost curve is crossing the average total cost at its minimum. I'm happy to post a video at some point explaining or teaching you a little bit more concepts on production and cost. Okay. Now, how do we visualize the other costs in this graph? Well, we start from, I need blue now. We start from this intersection point A, right, where marginal cost was intersecting marginal revenue, and how we got our profit maximizing quantity. Well, we use that and we draw a line up to touch the average variable cost, and we read it off this vertical axis. Now, in my class, I named this the dollar value of average variable cost. We do the same for total cost. We touch the total cost curve by extending the line from the intersection of marginal cost and marginal revenue. See that? And we can name this dollar value average total cost. Okay. This is great. So from here, we can figure out what variable costs will be. Remember, variable cost up here was Q star times ABC. So I hope this is making sense, that variable cost will be the area from 0 to Q star to this intersection. Let's call that intersection B, to that intersection B, to dollar value ABC down to 0. So our variable cost will go from 0 to Q star to B to dollar value ABC, and then back to 0. If you notice, our total revenue doesn't entirely cover our variable costs. What about total cost? Total cost goes from 0 to Q star to that intersection with ATC curve. Let's call that C. So 0 to Q star to C to dollar value ATC down to 0. So that will be our total cost. So our total cost will be 0 to Q star to C to dollar value average total cost, and then back to 0. So if you take a look at this carefully, our total revenue doesn't cover all of our total costs. Okay, so we figured out what total revenue is. We figured out what our variable costs look like on the graph and what our total costs look like on the graph. What about fixed costs? Okay. Fixed cost will be, or average fixed cost will be the gap between average total cost and average variable cost. And I will shade for us in yellow average the entire fixed cost area. So just shaded in yellow, that is our fixed cost area. So remember, fixed cost is calculated as Q star times average fixed cost. That is exactly this yellow box, right? The height of the box is AFC, and the base of the box is exactly Q star. Do you see that? Okay, so now let me write that area down. Fixed cost. Oh, let's get blue now. Fixed cost will go from dollar value ATC, pardon me, dollar value ABC to, let's go back up to look at it, dollar value ABC to B to C, dollar value ABC to B to C to dollar value ATC, and then back to dollar value ABC. So I'm tracing the entire box. Dollar value ABC to B to C to dollar value ATC, and then back to ABC. See. So children, I hope this has helped you, and this is how to visualize costs in the graph for perfect competition. Why are we able to do this much? Now, if you're coming from, or if you have just studied production and costs, all that was done in there was drawing marginal cost, average total cost, and average variable cost. But here we can do more because we have used some ideas about the features of perfect competition to figure out the profit maximizing quantity. That is why we can do a little bit more in these graphs. Okay, I really hope this helps you. Oh, by the way, this firm's demand curve, this horizontal line means it is the demand curve for each firm. So each firm's demand curve is perfectly elastic, right? Or horizontal. Okay, and why is it horizontal? It's because no one firm has influence over prices. They are price takers. Producers are price takers, or suppliers are price takers in perfect competition. I hope this helps you.